Hello my dear students, today chapter number 1 chemical reaction and equations, topic number 4 types of chemical reaction, part 2 10th science. In the part 1 we have already discussed about the two types. Now remaining three types will be discussed in this video. So before starting, let us just have a quick revisit what we have done in the previous videos. So we had learned about the definition of chemical reaction, how to write those chemical reactions and how to balance those chemical reactions step by step. We had also learned two types of the chemical reactions, with combination and decomposition reaction. And in this video, we'll try to cover the remaining types of the chemical reactions, with displacement reactions and redox reactions, means reduction and oxidation reactions. So now, first of all, let us try to understand what are the displacement reaction. Actually, there are two types of the displacement reaction. One is the single displacement reaction, another is the double displacement reaction. So first of all, let us learn about the single displacement reaction or only displacement reaction, single displacement reaction or simply displacement reaction. As the name itself indicates, a chemical reaction in which a part of molecule is displaced by another atom or molecule, that chemical reaction is known as displacement reaction. A more reactive metal displaces a less active metal from its salt. Repeat, a chemical reaction in which a part of molecule is displaced by another atom or molecule. A more reactive metal displaces a less active metal from its salt. For example, कोई अगर मानो कि पतला सा लड़का कहीं एक जगह बैठा है और किसी पेड़ के नीचे मानो कि छांव में बैठा है और एक हट्टा कट्टा आदमी आ जाए, ए पतले इधर क्या कर रहा है, तू बाहर धूप में जा, मैं इधर बैठता हूं. So this more active, this more powered person, this fatty person displaces, removes the thin person, पतले वाले को दूर कर देता है और ये मोटा वाला बैठ जाता है छांव के नीचे. मतलब कि जो मोटा है, जिसमें ज्यादा ताकत है, वो ज्यादा रिएक्टिव है, वो क्या करता है, जो पहले से छांव के नीचे बैठा है उस बंदे को हटा देता है. इन technical words we may say a chemical reaction in which this fatty person removes this thin person means a chemical reaction in which a part of molecule which is less reactive in nature will be displaced from its salt by more reactive molecule, that is known as displacement reaction. I think now the concept might be clear in your mind. So now what are the uses of the displacement reaction? Displacement reactions have a variety of uses. They are mostly used in the metal extraction process, flame photometry, acid indigestion and steel production plants. You might be knowing India is one of the large producer of steel. Large steel industries are there in Bokaro and West Bengal and Orissa side and Jharkhand. Ferrous, solid in the nature, when combined with the copper sulfate, aqueous in the nature, produces ferrous sulfate that is aqueous in the nature and copper that is solid in the nature, means copper crystals will be formed at the bottom, right? So let us try to understand this reaction. So in this reaction, in this single displacement reaction, ferrous, that is iron, loha, when ferrous is placed in a solution of copper sulfate, you can clearly see in the figure that copper sulfate is blue in the color. Remember, this color you will have to remember. Copper sulfate is blue in color when we put a nail or a blade. Nail or blade, they are basically manufactured or they are made up of iron or ferrous, right? So when we place a nail or a blade which is made, or anything, nut, bolt, etc., anything which is made of iron, which is made up of ferrous, inside a solution of copper sulfate, a magic starts. What magic happens? Ferrous, which is fatty man, which is more reactive than copper, what does it do? It displaces the thin man under the छांव, under the shade, from the shade of a tree. तुम यहां से हट जाओ. So ferrous, the active man, more active man, displaces कॉपर फ्रॉम द कॉपर सल्फेट सॉल्यूशन एंड फेरस वहां पर जाके बैठ जाता है और अपना साल्ट बना लेता है, फेरस सल्फेट, छांव अपनी खुद की बना लेता है, राइट? नाउ व्हेन फेरस has displaced copper, the copper sulfate solution has become ferrous sulfate, and hence the color of the solution has changed. Now the color of copper sulfate, which was blue initially, since now it has become ferrous sulfate, now the color is greenish in the nature due to the shade of the ferrous. And copper, वो बेचारा क्या करता है, पतला आदमी बाहर खड़ा रह जाता है. ऐसे ही कॉपर जो है वो नीचे मानो कि चिपक जाता है या फिर ब्लेड के आसपास चिपक जाता है, ब्लेड के ऊपर चिपक जाता है. एनीवे, सो रिगार्डिंग दिस डिस्प्लेसमेंट रिएक्शन वी मे से दैट फेरस when combined with the copper sulfate, it displaces the copper from the copper sulfate solution and it self becomes ferrous sulfate, liberating copper aside, and then copper will start depositing over the blade or nails, etc. Hence its color will also get changed. So copper sulfate blue in the nature and iron sulfate is in greenish in nature. Take one more example, zinc. Same thing is also applicable with the zinc. Zinc is also more active than copper sulfate. So what happens when zinc is placed in the solution of copper sulfate, right? Then zinc displaces copper from the copper sulfate and a solution of zinc sulfate will be produced, and copper will set aside itself in a corner कि भाई हम यहाँ पर ठीक है. Same thing also applicable to plum, lead. When lead combines with the copper chloride solution, when we put lead inside a solution, aqueous solution of copper chloride, copper will be displaced and plum chloride or lead chloride solution will be produced. So all these were the example of single displacement type in which single element, for example copper in all these three reactions, copper has been displaced by more reactive materials, more reactive metals, for example lead, zinc, ferrous, etc. Next is that of the double displacement reaction. The name itself indicates double displacement, right? So in case of the double displacement reaction, a chemical reaction in which there is exchange of ions between the reactants is called double displacement reactions. Means there will be displacement of two ions between the salts of different metals. A more reactive metal displaces a less active metal from its salt, just like single displacement reaction. So let us take the example, sodium sulfate Na2SO4. You might be knowing, you will have to try to remember these words in your own method. For example, Na2CO3. When we used to study in the classes, we were not able to remember certain chemicals. For example, Na2CO3. We used to just make fun of that, and we used to say Na2CO3, 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 right? So anyway, you will have to try to just create your own style of remembering. This Na2sulfur, Na2SO4, Na2sulfur SO4. So Na2SO4, that is sodium sulfate, which is aqueous in the nature, when combines with the barium chloride. Now what are these barium, sodium, chlorine? You will have to remember the periodic table at least on a glance way. At least you should remember, yes, these are the elements, these are the various type of the elements that do occur on the earth. So Na2SO4, that is sodium sulfate solution, when combined with the barium chloride, they produce barium sulfate and sodium chloride. Means ions have been exchanged. SO4 has been displaced from, sodium has been displaced from the sulfate and barium has been displaced from the chlorine. So sodium reacted with the barium chloride and it produced the salt sodium chloride, and barium has displaced sodium and barium sulfate has been produced. So two compounds have exchanged their ions, right? Na2SO4 when combined with the barium chloride produces barium sulfate and a salt sodium chloride. Since in these reactions two displacements are there of sulfate and chlorine, or say sodium and barium. So this reaction is known as double displacement reaction. Now, who is more active and who is less active? So if an item or an element which is more active in the nature than item which is lower active in the nature, so we may write the sequence. This sequence is known as reactivity series, an arrangement of elements in decreasing level of reactivity. मतलब कि सबसे मोटा उससे पतला उससे पतला उससे पतला उससे पतला, जो मोटा आएगा वो पतले वाले को हटाता जाता है ऐसे. So this type of arrangement in which different types of elements which have been arranged sequentially in such a way that of the reactivity of each element keeps on decreasing. For example, zinc is more reactive than copper, so zinc's place will be higher than that of the copper. So higher element in the series can replace the element from the itself from lower level. So this is all about the reactivity series, and that is what we have talked is something like this. सबसे पहले पोटेशियम, फिर बेरियम, कैल्शियम, सोडियम, मैग्नीशियम, एल्यूमिनियम, जिंक, फेरस, निकल, this tin SN, plumblum, hydrogen gas, copper, orium means silver, and last gold. Gold is the least reactive metal, right? So you can see over here that copper is almost third from the top, third from the bottom, means very less reactive metal. सबसे पतली है अपनी भाषा में बोले तो, so it can be replaced by almost all items, almost all element. So we will have to, my dear students, remember this series so that you can understand whether this element will be able to displace or not. You will have to create your own style of remembering this series. For example, kaba kana maga alla janna finisi paba. For example, this is the way I have remembered. You may try your own way. For example, kaba kana maga alla janna finisi paba. 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 Ka potassium, ba barium, ka calcium, na sodium, Mg maga al jana. Kaba kana maga alla jana means zinc, fe ni sa paba. Kaba kala maga alla jana finisi paba. Kaba kana maga alla jana finisi paba. I think you might have remembered by this time. Anyway, so next topic is that of the oxidation and reduction. Now, what are the oxidation reactions? Oxidation reactions means a reaction in which substance gets or gains or combines with the oxygen. Means oxygen gets attached to that compound. So those type of reactions are known as oxidation reactions. And in case of the reduction, reduced means oxygen is liberated, oxygen will be removed from that substance. They are known as the reduction reaction. Repeat, in case of the oxidation reactions, oxygen will be attached or combines with the compound. In case of the reduction reaction, oxygen will be removed from the compound. Let us take certain example. Two atoms of the copper in the solid nature, solid state, when combined with the oxygen in gas state with the heat, they produce two molecules of copper oxide in the solid state. So this is called a balance equation. Copper oxide when reacts with the hydrogen gas, they produce copper and water. Now, how can we say that these are the oxidation or reduction reaction? In the first reaction, when you see copper reacts with the oxygen, means it acquires oxygen, it gets oxygen. So we may say that copper is getting oxidized in the presence of heat. We may say copper is getting oxidized in the presence of oxygen and producing copper oxide, hence this is oxidation reaction. Whereas in the next reaction, copper oxide when combines with the hydrogen gas in the presence of the heat, copper oxide liberates oxygen. Oxygen is removed from the copper and oxygen combines with the hydrogen, hence hydrogen gets oxygenated and copper gets reduced. So actually it is the reduction reaction for the copper and oxidation reaction for the hydrogen. Guess which compound gets oxidized and which one reduced. Already I have answered, so now nothing to answer. Now what are the redox reactions? As the name itself indicates, redoxide, reduction plus oxidation means the reaction in which both of these process takes place at a time. Copper oxide gets reduced into copper and hydrogen get oxidation with that of the oxygen to H2O. So these are this type of the reaction in which both oxidation and reduction takes place at a time. This type of the reactions are known as redox reactions, means reduction, oxidation. So these are the known as redox reactions. These are few more examples: zinc oxide and carbon. Oxygen gets removed from the zinc oxide and carbon monoxide. See, only one oxygen there. Mono means one, di means two, duo means two, tri means three, quad means four, penta means five, hexa means six. So you will have to remember these words. So zinc oxide, zinc monoxide, it's not spoken like that. Zinc oxide, when combines with the carbon, they produce zinc and carbon monoxide, means zinc oxide gets reduced to zinc, means reduction of the zinc oxide to zinc. And in next example, manganese oxide, when combined with the 4 molecule of the hydrochloric acid, produce manganese chloride and 2 molecules of the water and chlorine gas. Now try to just recollect what was the color of chlorine, my students. Students, can you remember what was the color of chlorine gas we had discussed in the previous video? Just pause the video and try to recollect. Just put the answer in comment. What was the color of chlorine? It was lime, yellowish lime color. I think you should remember. Anyway, so in this equation, manganese dioxide, oxygen from manganese gets reduced. So this is also a reduction reaction. Now in the next video, we'll try to elaborate the effects of these oxidation reactions in our life, with corrosion and density, how they affect us. These two effects will be discussed in the next video. For more such videos, simply log on to YouTube and search RK Sir's Free Education. Thank you.